Hello and welcome to Decoding the New Economy. Today I'm talking to David Snowden, the Chief Scientific Officer of Cognitive Edge. We're going to talk about frameworks for solving intractable problems, which is a big challenge there, David. Tell me about Cognitive Edge.
We're a research company set up 10 years ago when I left IBM. We do a mixture of method creation, software creation, and we've got a network of 4,000 to 5,000 people worldwide now. So our whole business model is to create capability for small independent consultants or in-house consultants.
Yeah, so what sort of clients do you have yourself?
Myself, in terms of what I'm working at the moment with Boeing, with Intel at one end, with diabetes prevention, with a regional health authority in the UK. It tends to be pretty diverse.
Right. So how do you go about approaching these intractable problems?
Depends on the problem. We actually took an approach some time ago about taking a natural science perspective. So we draw on complexity theory, anthropology, cognitive neuroscience, and then we build from that.
Right.
So we're very much opposed to the case-based approach which you see dominates most of society. Yeah, so kind of like the idea there is you find what other companies have done, you imitate it.
Right.
But apart from the fact you can never imitate the context, no company has ever succeeded by imitating other people. They succeed by doing things differently.
Yeah.
So we can actually take what we know about how the human brain works and help people work that out. So the principle is find an intractable problem, which is a phrase I prefer to wicked problems.
Okay.
Because it describes a real problem and look at how you can solve it. And there's two basic methods on that. One is you move to what's called safe to fail experiments. So instead of getting everybody to try and agree on one approach, you identify any coherent hypothesis, and it's easy to agree you're coherent because I don't have to agree you're right.
Right.
So that's a conflict resolution device.
Yeah.
And any coherent thesis gets a small amount of money to run a small safe to fail experiment in parallel. And what you then find is completely novel solutions emerge because you built diversity. So that's one approach. The other approach, which uses our software SenseMaker, means we can actually capture self-interpreted narrative from large populations of people, which means effectively we can use the whole of the workforce or the whole of a customer base as a problem solver, as a network to help you solve problems.
So it strikes me that you're getting around some of the risk aversion in big organisations because you've got those smaller safe to fail, so people aren't going to be challenged by that risk.
Yeah, I think the other thing is you're dealing with problems that conventional methods have failed on anyway. So it's less risky, and there's an increasing number of intractable problems. I think we're also making statements that people understand that you can't afford, for example, in market research these days, to spend 3 months commissioning something, 2 months gathering the data, 1 month interpreting it. Right. If we actually create a network of your customers, a sensor network, we can give you data in real time. And that reflects how we started in counter-terrorism.
Okay, right.
Where you've got to do weak signal detection, you need fast real-time feedback loops, you need to intervene very quickly. And there's no difference between a terrorist, a customer, a citizen, and an employee.
Right.
They all represent the same problem, which is how the hell does a large authority make sense of multiple fragmented data? And that's where we work.
So it seems that you're touching on quite a few of the IT industry buzzwords there with the big data analysis, Internet of Machines as well. You mentioned
yes and no. I think there's probably a big difference. And I've gone through big data hypes 3 times in my career, and it's kind of like they have this belief that there's one algorithm to rule them all, and in the darkness bind them. Right?
Yeah.
Our emphasis is that fundamentally human beings can do things that computers can't.
Okay.
And every time people get hyped on big data, they think you can just gather the data, write an algorithm, and it will tell you what Al Qaeda is going to do next. And we know that's not the case.
Right.
The role of technology is to present information to human beings, for human beings to use human intelligence. And that's the concept of human metadata, human sensor networks. So we work on that. So our concept is technology augments human intelligence, it doesn't try and replace it.
So that term human sensor networks, explain that to me.
Well, I'll give you 2 separate examples, commercial and non-commercial. We're working with the Welsh Audit Office at the moment on what will be an experimental project where children will go into their communities 3 or 4 times a year, gather stories from those communities about what worries them, what disturbs them, what they want, which is a great school project.
Yes.
The kids are very good at gathering stories. They'll help the adults interpret their own stories into a quantitative framework. So that actually gives us much better data than you get through conventional market research, and it gives you continuous feedback.
Yeah.
I can then use those school children to ask questions in real time, so I can ask questions of public policy and get results back within 24 hours.
Right.
On a commercial case, we're now actually getting people moving to a transport system. and incentivised by small discounts to tell stories as they enter it, as they leave it, throughout it. So that big data can tell us where you travelled. The narrative approach can tell you why you travelled, which is more important. But now when I've got that network, I've got about market research, but I can also, if something goes wrong, I can use that network to communicate. So now instead of a bare announcement, somebody next to you is telling you what's going on. And I can also use that network to ask questions in real time.
So I would imagine then that if someone beside me stood, I've got a lot more trust in that channel as well.
Yeah, it was interesting. I got stranded in Toronto airport with the polar thing. It's a bloody nightmare, right?
I can imagine.
Sort of, 2 nights sleeping rough, and it was kind of every hour it was going to leave. They got us on the plane, they took us off the plane, they didn't get the meal tokens. I've got a whole saga on this. But either way, it got to the point where I was getting to I now decided I could use our principles to devise a whole new technique for airport management. Right?
Sure.
One of the things we're now working on that is to activate frequent flyers. So frequent flyers have smartphones, they can be activated by the airlines, and they can act as a communication mechanism. So because a big problem in a disaster like that is the communication gets linear and uncontrolled. If you can make the distribution non-linear, you can do very powerful things.
I imagine for big organisations too, with employees where you've got rumour mills and so on working, that's a much better way of managing.
Now with one water company at the moment, we've moved their field notebooks onto the software. So we, for example, instead of, let me give the example, when people fill out an employee satisfaction survey, they're often asked a question like, does your manager consult you on a regular basis, 0, not at all, 10 all the time?
Sure.
Well, you know what the answer is, they won't. And you've got several managers, and sometimes they do and sometimes they don't. So it's a nonsense question, like most questionnaires. We say, what's the story you tell your best friend if they're off the job in the company? Then we ask them to interpret it on a triangle between the manager's behaviour with altruistic, assertive, analytical. Where you don't know what the right answer is. So that makes you think about it, so the answers are more valuable. And typically in a survey there'll be 6 or 8 tries. So we found, for example, with water engineers, they don't like classifying things into boxes, but placing problems onto triangles is easier for them. But then the same system, they can interview customers and get customers to interview stories, and they can see how about they feel about the job. So you put one system in place which does customer survey, employee satisfaction survey, and field notebooks, and allows you to integrate them. And that's the really exciting thing, is simple systems allow you to get very sophisticated in the use.
It seems to me too that that approach is going away from what a lot of people are trying to do, putting structure into unstructured data. You seem to be unstructuring that data.
Yeah, we're fragmenting it. What we're doing is we're saying, human beings like mess. The key concept called messy coherence. So my study is a mess at the moment because it got tidied up over Christmas and it's gradually degenerated. When I get back in a week's time, I've got a new desk, a new chair, because I need to be upright and down, right? So everything's going to get reorganised. It will be neat and tidy and immaculate after 2 days. Nobody in the family will dare go in there. Then it will disintegrate again. So I go through a process of structure, destructure, structure, destructure. The trouble with most organisations is they do a one-time structuring. They create a taxonomy. And taxonomy actually sounds like taxidermy and produces the same result. Or they put in a rigid process map, which is one-time defined, or they build enterprise-wide resource planning software, which means they can't update it. So they lose the dynamic capability of responding quickly. Now, the new concepts, and it's like object orientation in software follows this. Effectively, software needs to be small bits of software which interact with people to create applications through evolutionary processes, rather than a one-time big design where you put too much structure in.
So static, flexible,
you want dynamic, free time flow, things where you can change small bits very quickly, you can be responsive. And what we're trying to do is to create a condition under which big companies can be as dynamic as entrepreneurs, because entrepreneurs create big companies, then they become static. And then the patterns of their past success breed the inevitability of future failure. If we can actually decouple but have some structure, and we can create that sort of dynamic control, you actually allow larger companies to behave in an entrepreneurial way, and that's one of the key things of this.
So where do you see all of this going in the next 5 years?
I think it feels a bit like the 1980s when systems thinking came in. So systems thinking came in with define the future state and close the gap. Complexity thinking, or more specifically cognitive complexity, is kind of like the next big paradigm. And it says focus instead on accurately describing the present, identify what you can change, out of what you can change, where can you monitor the impact, and out of those things, where can you amplify success or dampen failure, which means you evolve forward to a future state which you couldn't have anticipated, which is more sustainable.
Right.
Now I think that's a huge switch, but it's as big a switch as happened in the 80s, it will have the same impact. And you'll see it's happened in the 80s. Big companies go under because they don't make the adjustment.
Sure.
And you'll see the same thing happen now.
Yeah, and how much you see technology's role in that as opposed to cultural?
I think the thing about now is technology is becoming a tool.
Yeah.
And you can't separate tools from culture. Here we're homo faber, we're tool makers. So for example, after 2 or 3 years of people using iPhones, if you don't know it, their brain is physically changes because the technology changes the way we think and act.
Yes.
So for example, when I do a walk in New Zealand on the weekend, I know I'll use 16 or 17 different apps actually during the walk. So that's a tool use. The point is technology now is pervasive, and it wasn't in the 80s, it was just novel. So people treated it as a fetishistic device. Everything had to be done in computers, and we actually used a computer model of the human brain, which is really ridiculous, all right? Because the human brain is different. Now, instead of having to re-engineer your hand to fit the tools now fit your hand.
Right.
And at that point, they allow you to scale human capability.
Yeah. Well, David, it's a very fascinating area, and I probably talk for a lot longer on this, but thank you very much for joining us.
Real pleasure.
And thank you for joining Decoding the New Economy.